Alright, today we're going to build a little solar-powered UPS, basically. A little solar charger, battery-powered system. So, the heart of this is this little guy. I just ordered this from eBay. It came from China. It took me about a month and a half to get it. MPPT solar charge controller. This one happens to be 24 volt compatible, which is what we're going to run. And it has a 10 amp current, which is more than sufficient. One thing it doesn't say is it doesn't say the wattage in either on the unit or in the manual, which is a little odd because it doesn't tell me 10 amps at what voltage. I assume it's 10 amps at 12 volts, but it could be at 24 volts. Probably not. So it's probably 5 amps at 24 volts, which is what we need to run. What we're powering with this comes directly, needs 24 volts exactly, so this is going to be perfect. Alright, so to do this, I am running two 5 amp hour batteries, 12 volt batteries. We're going to run these in series to get our 24 volts. Little sealed batteries do a great job. They run pretty well. This is going to have to run pretty hot, so these are rated for 25C, which should be plenty. We also need some little stake type connectors. These guys, I just got these from Home Depot. They're rated for 10 gauge cable, which is about what we're going to be using. And I'll show you a special trick that I use with these. You can crimp these, but I do not like doing that. They don't work very well. It needs a pair of pliers. I use these little diagonal cutters. These are fantastic. I have had these for years, and they're super sharp and they work really well. And then this is the box that these came in from Home Depot. You can get these for like $2, I think. It comes with 10 of them. We only need 4, but it's the box. And then this is one of the best deals I have found. So you can buy wire at Home Depot in the form of jumper cables like this. One thing to note, they say on the package that it is 8 gauge. It is not 8 gauge. It's probably closer to 9. They're cutting it a little close so that they can probably sell it cheaper. But this 12-foot cable cost me $9. I just cut the ends off. Alright, so the first thing we're going to do is I'm going to disassemble these. You can actually crimp them, but it is much better to solder them for our application. And they come apart really easy. You just grab them with 2 pliers, big pliers and little pliers. Just grab a little plastic and give it a little twist. Oh, this one's gonna be stuck. Usually it just comes right off, like that. Ta-da! I'm just gonna do that to all of these. Get a little twist and pull. And the reason we're doing this removing of the safety part is because we want to solder them. We don't want them to come apart. Usually if you get them in there really good, they don't come apart, but we want to make sure they don't. Okay. Now for the actual wire, we can strip this back with the cutters. I'm just going to use a knife because it's a little faster. I'm just strip a little bit back. Not this much. Try not to cut the little wires because they're really small. My knife cuts through them. And I'll show you that this is not 8 gauge, even though it claims to be. This is a 10 gauge connector. Look at that. Can't tell me that's 8 gauge. So these are probably more like 10 gauge wires, but they're still a good price for 10 gauge. Look at that. Perfect. I want to make sure that we're not going to block the little spade here, so we can take these off and cut this, but I like to do it while it's on here. Take the cutters, get in there real tight, and just trim the little ends. It'll give a nice clean appearance. Alright. Crimp this down just a little bit with the pliers, just so it doesn't slide off on us. You can actually probably crimp this really tight and it will stay, but oftentimes they pull off on me, so we're going to solder it, and then we know it will stay. So I'm just going to use this little bit of solder here that I have, even though bigger gauge wires fine, I just don't have any with me. If you have helping hands, that's great, but you don't really need it for this either. It's pretty quick. Alright, we want to start by getting it hot, but we want the solder to fill the joint. So the key to soldering is you want the workpiece to melt the solder, not the iron. So I should be able to touch this workpiece here, and this should melt the solder, not touching it to the iron. If you're touching it to the iron, you'll get a cold joint. It's not hot enough yet. There we go. See how it's melting the solder by itself now? It means it's hot enough. So it will flow down on the inside of this into the actual copper of the wire, which is what we want. Alright, I'm going to move the iron to the bottom. Still heating it the same way. And then when this is hot enough, it'll just melt the solder right in. See how it's sucking it in there? That's perfect. You don't want to put too much in, because it'll make a big mess. There's a lot of wire in there, so we do need quite a bit. I'm going to do some back here. See how it just sucks it right in? You don't want it to be too much, because it'll glob up. And it'll break our connector if it gets down in there. We don't want that. That's probably good. And that will never ever come off of there. That is stuck. So we need a red lead and a black lead to go into the charge controller. And then we need one to connect these two to make this series. Like that. Or probably like that. So that's going to be this one. It needs to be about that long. So we're going to make it that long, just to make sure I'm not making it too long, or they won't fit together right. So about that long. That's how long we need it to be. Short little jumper. We're going to put heat shrink on this also to clean it up. If you have it, it works great. Because we did take off the little safety non-conductor plastic part. Just cutting the jacket off with a knife. If the wire's a little bigger, you might have to spread this open a little, but we shouldn't have to because this is not 8 gauge, it is 10 gauge. Even though it says it's 8 gauge on the package. Alright, I missed a couple. It's probably a little bit bigger than 10 gauge, but it's definitely not 8. That's pretty tight. So, to open it, we just stick something in here and just twist it. I'm not closing this very tightly. Just enough to open that. Just a hair. Alright, I want this to be the same orientation as that because it's going to be a jumper, so I want this to be flat, like so. So now when it lays down, it'll sit flat. I'll have to twist it around. I'm just going to clamp this down a little bit so it doesn't slide off. Doesn't take much. Just squeeze it in a little tiny bit. This cable fills this connector too, so this is the right gauge cable to get the most current you can out of these little things. Alright, again, this is we'll do this one real quick, and then I'll do the other ones. Just don't want it to move around. Oops, I got one trying to get away. You don't want any of the little wires. You want as many of them in here as possible. If you lose 2 or 3 of them, it's not a huge deal. You know, even 10. You do lose some capability of the wire, but it's not incredible. You don't want them all frayed out, though. You want them all in there. So if you have to cut one of them off that you can't get to stay in, that's fine. But if they are frayed and sticking out, then they're gonna miss and short out on something likely. Soldering something big like this is much different than soldering something small because it takes so long. I just put a little bit on the iron. The reason I do that is so it makes a good connection to the piece we're working on. If you don't, that connection it's kind of like filling all the little voids, because there's not a perfectly smooth surface between the iron and the workpiece. So you do want to get a little bit on the iron. You can touch it just to get it started. Otherwise it won't ever heat up the piece. Then, see how that's heating it up? That's what you want. So the actual connector is melting the solder, not the iron. That's perfect. And then it will get hot enough to melt the copper. See, the copper, I can hear I'm hitting the copper with it, not hot enough to melt the solder. It's not good. It's just outside. So I'm going to move this down here to heat it from the bottom now. And then I'm going to get the copper on the inside here. Look at that, how the copper is just sucking it in right now. Bare copper just sucks up solder, drinks it. Do you want to get a little bit more back here? There we go. Yeah, the copper's taking that now. This one's not as pretty as the other one. It's got all that nasty flux on it, but it'll be fine. Another difference when you're soldering something this big is that you got tons of time. You're not really worried about melting this jacket. It is hot. I mean, I can hold it, but it's hot. It's uncomfortably hot. But I'm not melting this jacket back. If this was a small wire, this would just melt back really fast. Right, so I'm just nicking the jacket on these. It cuts right through. Hey, I didn't cut a single one that time. Oh, I guess I did cut one. I cut one. Sometimes these fit right on, and sometimes they take a little coercion. I don't think there's a high tolerance when they make these either. Alright, it's a little too tight, so I'm not gonna wreck my cutters by doing this because I'm not cutting hard enough. You have to be very careful with these that you don't dull this blade. So I'm just very lightly pinching it. And I don't have my lineman's pliers on me either, so this normal set of slip jaws is going to be just fine for what we're doing. Right, again, I'm getting that really tight back in there. I'm going to trim off the excess. We want to make it just a little bit too long so that we have some to trim off. We don't want it to be too short. If it's too short, you're going to not have as much surface area connecting the two. It won't be as strong, and it won't conduct as much. Alright, so that's just about perfect. Again, I'm not going to use the helping hands, we're just going to do this fast. Same thing, third time. I'm choosing to put the iron right here where all this copper is because it's the mass. It's the biggest spot where they can come in contact. One nice thing about doing wire this big is you can take your time. Like when you do little wires, you have to be really accurate and really fast. But when you do big ones, you have so much time that you can just take it easy. It's actually easier to do big wires than little wires. So if you're learning and you're starting out, this is a lot easier to do. And you can see very clearly when it gets hot enough to melt. And this is not hot enough yet. Can you get a little closer in there and show how tight that is? See how this little bit that when you touch the iron, it's actually melting it. But out here, this is not hot enough. There, it's starting to get hot. I don't know if you can tell, but it's also shiny. The shiny stuff is hot. The not shiny stuff is not hot. Losing my connection here. get in there and get all that copper and get a really good bond between that and the corners. We don't want to put so much in that it's dripping off the bottom. That's what will happen. We'll get a big giant puddle underneath that's hanging. See down here, this is hot enough too, so I'm going to get some back in this. See how it's clinging to the outside? That's not good, we don't want that. It doesn't look good and it's totally unnecessary. It's not doing anything to have the solder on the outside. Alright, that's basically done. Let it cool and we'll put heat shrink on it. It's melted the jacket a little bit, and up here it's uncomfortably warm to hold that. I can hold it here. So it also takes a long time to cool down, in addition to taking a long time to heat up. Alright, we'll do the other one. Alright, so the way this is wired up now, we're going to do one more thing on this other side. And I'm going to tin these, is what it's called, which is putting solder, tin solder, on the end of them so that they don't fray out. You can shove these in there and they'll work, but they tend to fray every which way. You can do two things to keep them from doing that. You can put little caps on them, which are basically these with a long skinny part that sticks off. You can do that, but I found it's just as easy to just tin them real quick with an iron. Now these are going to have to strip back farther because that's way in there. The actual conductor is back in there probably closer to ½ an inch. So I'm going to strip off a little bit more. You don't want to go too far, don't go too crazy with it, because you don't want it sticking out. But what we can do is we can just trim it to length. We don't want the conductor sticking out where it can short. So tinning the wire is exactly the same as putting the connector on it. If you don't know how to tin a wire, again, we don't want the iron to be melting. We want the conductor to do it. So I'm going to put the iron on the bottom like this. There's a little bit of solder on it to make a good connection, and we're going to wait until the copper melts the solder, and it will be very obvious when it does because the copper soaks it up like a sponge. My hand is getting pretty hot back here, so I know it's getting hot up there. There we go. You see how it soaked that up? That's exactly what it does. There it goes. That's hot enough. Okay, so we don't want a lot. We just want enough to coat it to keep it from fraying. We don't want it to get massively thicker or something like that. It just soaks it up. Okay, see how it's shiny? That means it's still hot and liquid and flowing. It will be very dull gray. Whoops. Soaked up all the solder off my iron. It will become a very dull gray when it cools. That is exactly how it goes. See how it's melting it way back there? It's nowhere near the iron. That's perfect. Alright, now we're going to hook it up. Alright, so this is just attached to the controller. The battery leads stuck in there and tightened down. And this is one thing I love about this cable. It's really clean appearance. They're cut the same length. Alright, so I just fast forwarded through the boring step. This is with the batteries hooked up. I just put the heat shrink on the end of them here and plugged everything in. This one I had a little piece of red, so I just stuck right on there. Color doesn't do anything. So this is connected in series, red to black. Red goes out, black goes out. It's 24 volts. I already measured it with multimeter. And then I hooked it into this guy. The instructions say hook battery up first. So hook battery up first. It says normal and the load is active. I believe it has a relay that shuts off the load if the batteries are too low. Alright, so now we're going to hook up the power, which is what says hook up secondly, and then the load hook up third. So we're going to hook those up right now.